Hi everyone, I just wanted to give a quick update on our Black Canyon City Landslide coordinates. So I've put an updated slide deck here on our website, and I also updated this coordinates file. So if we just look at that, so this is all unchanged, but when you come down into here, there's some new things. So I went back through and I started at the very beginning with the coordinates from Peary and Helmy, and I projected those from latitude, longitude to UTM, and that's what this easting, northing, and elevation is here in this table. And then I matched those up with proper benchmarks from 2024, so that's what this matches. It's just a position in the list. And I projected the latitude, longitudes from 2024 to UTM as well. And then I carried along the elevations. And so then the other thing I did was, remember, in this approach, what I've done is I assumed that benchmark 1 didn't move. And so therefore, I took the difference in position from benchmark 1 in the two measures, and I used that as a correction. And so then the new positions, the easting, northing, and elevation, are the ones where we already adjusted the whole network to account for benchmark 1 not moving. So I've done this for you, and because I felt like it was confusing the way I explained it. And so a couple of things just to see, and I did this in MATLAB just to help me keep track of things. So you see the main commands are these ones here. This proj CRS just defines the projection, and then the proj forward goes from latitude, longitude to UTM. And I did this with both WGS 84 and as if the 2024 data were in NAD 83 and didn't make a difference. So I don't think that's the problem. So here in this plot on the right, you can see the arrows are the exaggerated vectors that you would have between the two benchmarks, and so you see the whole network was moved to the left apparently. So that's with benchmark 1 not corrected. And then when I do correct it, so the benchmark 1 displacement is 0, as I've shown in the lower left, so kind of reverse this vector and apply that to all of them, then the displacements are relatively smaller. And so here's the answer basically for what I get in terms of the displacements, and that is that apparently everything moved to the west on the landslide, and the largest vector here is 23 centimeters. So most of them are smaller than 23 centimeters. So if you look over here, you can see that's this 17 that was 22 negative to the east. So that means it moved 22 centimeters west and 7 centimeters north. But most of them are small, very small, kind of. That's the biggest one, and it's 20 centimeters. The elevations barely changed at all. These would be in meters, so this is at the centimeter level. So I think we don't have good evidence for meaningful motion of the landslide, at least based on the benchmarks. There's still some residual apparent motion, but that seems to be error. It's something I'll continue to work on in future surveys. But I wanted to explain this to you, and if nothing else, you can say that it looks like it has had less motion than 23 centimeters probably. There could be something in there, but it also, the sense of motion doesn't really make sense. It's kind of as if the interior of the slide was shortening instead of extending, which is inconsistent with what we see in terms of the fracture pattern. The other thing that I wanted to point out you could mess around with is, remember I showed this vertical differencing, just the subtractions, and I showed this one, but remember you can also, you could try to mask it to cut out smaller pieces to study more in the interior, where we think the errors in the SFM between the two DEMs might be lower. But you can also just do a simple change this display and do this min max where you kind of trim the edges of the what you display. So before, if you look here, the range is like -5 to -55, whereas maybe most of the signal is a little bit closer to the middle of that range, so like -35 to -15. So you could play around with that a little bit to see if you tease out any differences that you feel like are meaningful. You could do that as well for the difference with the LiDAR. There's obviously a big sort of bunch of noise that's over here from the 2024 SFM. So again, if you kind of pick some place that's more well constrained with the ground control, there might be something interesting. But that's a way to look for it just in a visual sense.